At the heart of Miami, a stunning concrete structure was reaching for the skies. This landmark was 1000 Museum, the last soaring tower designed by the talented Zaha Hadid. The innovative design had the entire support system on the outside, creating a beautifully curved exoskeleton that embraced the building. To bring this vision to life, engineers drilled the deepest foundation piles in Miami at that time, poured over 7,600 cubic meters of concrete continuously for 24 hours, and carefully assembled more than 4,800 unique GFRC panels, all the way from Dubai. As the tower was still taking shape, Hurricane Irma, one of the fiercest storms in Florida's history, charged straight for Miami. In this video, join Datascope as we delve into one of the most audacious engineering feats ever realized in the United States. Nestled at 1000 Biscayne Boulevard in the vibrant heart of Miami, 1000 Museum stands as the crowning achievement of the renowned architect Zaha Hadid, a testament to her visionary work before her passing.
The tower rises about 216 meters tall with 62 floors, but its design followed a completely reverse philosophy. Instead of hiding the structural columns inside, Zaha pulled the entire load-bearing frame outward, creating a flowing organic exoskeleton that wraps around the tower like the shell of a giant scorpion. This dramatic shape eventually gave the building its famous nickname, the Scorpion Tower. With only 84 ultra-luxury residences inside the entire skyscraper, every apartment was designed like a symphony of curves, with no two-floor plans exactly alike. At the very top, the tower even features a private rooftop helipad. But behind that mesmerizing beauty was a brutal engineering story filled with nightmares involving concrete, formwork systems, and construction tolerances so extreme that they could make even experienced engineers nervous. Before the scorpion-shaped tower could rise into the sky, the engineers first had to confront something hidden deep underground: Miami's geology. The area was formed on porous limestone that had been eroded by seawater for thousands of years, creating countless voids beneath the surface, almost like a giant sponge. To overcome this challenge, the engineers developed the deepest foundation system ever built in Miami at the time. More than 277 foundation piles were installed deep underground, with each pile drilled to depths of over 54 meters. First, engineers drilled through the porous limestone layer, creating large diameter boreholes. Then reinforced steel cages were lowered into the deep shafts. Finally, high-strength concrete was pumped into the piles, turning them into gigantic nails firmly anchored into the stable limestone layer far below the surface. After the 277 piles had been drilled 54 meters deep into the ground, the next step was to create the foundation mat, a gigantic concrete slab designed to evenly distribute the weight of the 62-story tower across the entire pile system below. The pour required around 7,600 cubic meters of concrete. To transport that enormous amount of material, the construction team mobilized nearly 1,000 concrete trucks, lined up continuously and pouring concrete into the site nonstop for 24 straight hours. As concrete cures, it generates heat internally. If the temperature becomes too high, the entire structure can develop hidden cracks as it cools down, potentially damaging the foundation from the very beginning. Because of this, extremely strict rules were enforced. The concrete temperature before pouring had to remain below 35 degrees Celsius. Any truck exceeding that limit by even a single degree was immediately rejected and forced to return to the batching plant. From the foundation up to the 15th floor, the external skeleton of 1000 Museum was built using traditional cast-in-place concrete methods. The exoskeleton columns formed sweeping curves and branching organic geometries. Each floor required its own custom formwork system, handcrafted to create flowing shapes that never repeated from one level to another. The construction team had to assemble large wood and steel formwork systems, pour concrete on site, wait for it to cure, then dismantle the molds before moving everything up to the next floor. But as the tower climbed higher, the columns continuously changed shape. Every new variation required the entire formwork system to be redesigned and rebuilt from scratch. Costs began to rise rapidly, while construction took longer and longer. Most importantly, this method was almost incapable of producing the smooth and continuous curves that Zaha Hadid wanted. The edges still looked too rough, and the surfaces lacked the level of smoothness required for the design. It became clear that cast-in-place concrete was not the right solution for a fully curved tower. As a result, the engineers were forced to search for a completely different construction technology. Above the 15th floor, instead of using traditional cast-in-place concrete, the engineers switched to a material that had never before been used as a load-bearing structural system for a high-rise building: GFRC, glass fiber reinforced concrete. GFRC could create the smooth double-curved surfaces that conventional reinforced concrete simply could not achieve. But there was one major challenge. Producing thousands of unique GFRC panels required a factory capable of manufacturing extremely precise molds. Eventually, the team found a partner in Dubai, a city already experienced with highly complex architectural projects. Around 4,800 panels were handcrafted, with every single panel using its own custom mold and unique geometry. No two panels were exactly alike. To produce these glass fiber reinforced concrete components, workers first sprayed layers of cement, sand, and glass fiber mixture into specially designed molds. The panels were then left to cure before being sanded, cleaned, and surface finished. Once completed, each panel was secured inside custom support frames. The entire shipment was packed into containers and transported more than 12,800 kilometers from Dubai across the Atlantic Ocean to the port of Miami. No high-rise project in the world had ever attempted such a complex intercontinental supply chain before. After their long journey from Dubai, the 4,800 GFRC panels finally arrived in Miami, and the installation process for the tower's external skeleton began. Hundreds of meters above the ground, workers used cranes to lift each GFRC piece into position, wrapping them tightly around the curved reinforced steel core before locking everything in place with anchoring systems connected directly to the floor slabs. Once the panels were secured, ultra-high-strength concrete was pumped into the hollow spaces inside. As the concrete hardened, the steel core and the GFRC shell fused into a single load-bearing structure with smooth flowing curves. Unlike traditional formwork, these GFRC molds were never removed. They permanently remained in place and became the finished exterior surface of the tower itself. But in reality, the engineers quickly discovered a brutal rule. A panel misalignment of just 3 millimeters on the lower floors could accumulate into nearly 25 millimeters of deviation at the upper levels after dozens of floors were stacked together. Some panels were even forced into place so aggressively that they cracked directly on the construction site. The team had to immediately stop the concrete pumping process, seal leaking sections, and clean everything before the concrete hardened completely. GFRC technology had originally been expected to accelerate the project and shorten construction by nearly 6 months. But the extreme complexity and near-zero tolerance required during assembly were now pushing the entire construction site to its limits. Before reaching this point, however, the project had already gone through a major loss. In March 2016, when 1000 Museum had only completed its foundation and was slowly rising above the ground, shocking news shook the entire project team. Architect Zaha Hadid suddenly passed away from a heart attack at the age of 65. Her sudden death sent a seismic shock through the project, shaking the morale of more than 400 people working on the massive construction site. This moment completely changed the nature and mission of the project. 1000 Museum gradually became a legacy in the truest sense. The final high-rise building, personally approved by Zaha Hadid before she left this world. In September 2017, when the building had risen to the 51st floor, Hurricane Irma struck Miami. Sustained winds reached more than 160 kilometers per hour, with gusts at times reaching up to 280 kilometers per hour, equivalent to Category 4 and Category 5 strength, making it one of the most powerful storms in Atlantic history. The entire construction site had to be evacuated immediately. Only the project management team and a few structural engineers stayed behind to secure the temporary glass panels, lock the sliding doors, and cut off power to the entire building. They were worried that the GFRC concrete columns, which had only been partially installed and were not yet fully completed, might be torn apart by the wind, or that the joints between the panels and the steel core might come loose as the storm swept through. After the storm passed, the team returned to the site and witnessed a chaotic scene inside the building. Drywall ceilings had been ripped apart by the wind, temporary walls had been blown away, and rainwater had poured into dozens of floors through areas where the glass had not yet been installed, damaging many interior materials and pieces of equipment. But the main structure, the exoskeleton, remained standing. Not a single exoskeleton column was cracked, broken, or shifted out of its designed position. While many cranes at nearby construction sites were toppled by the storm, the Scorpion Tower proved that its seemingly delicate curves actually had an outstanding ability to deflect wind, allowing airflow to glide along its distinctive curved surface. Hurricane Irma became the most expensive real-world test of Zaha Hadid's design, and it passed with a perfect score. After surviving the fury of Hurricane Irma, 1000 Museum officially entered the most dramatic acceleration phase of the entire project. The surface damage was quickly cleaned up. More importantly, after a series of errors and difficult adjustments on the lower floors, the construction team finally decoded and mastered the GFRC installation technology. Each GFRC panel was now not only checked for dimensions at the factory in Dubai, but also fully digitized. Every panel was 3D scanned, compared with the BIM model, and checked for possible clashes before it even left the container. On the Miami construction site, survey engineers installed a real-time displacement monitoring system. Every joint and every steel pin had its own coordinates. Instead of fixing mistakes after installation, they detected misalignment while the panel was still hanging from the crane. Each work shift was reorganized. In the morning, the team measured and adjusted the anchor pins on the floor. In the afternoon, they lifted and installed the new panels. Thanks to these improvements, the construction speed began to increase. At first, it took weeks to install a single balcony, but at the peak stage, the team set a record by completing the exoskeleton of one entire floor in just 6 days. The constantly changing shape of the exoskeleton columns, which cut through the living spaces, forced the interior engineers to reset the entire drawing coordinates for every floor. Every partition wall, wastewater pipe, and even the positions of 6,000 fire sprinklers and 8,000 ceiling lights had to change compared with the floor directly below. Just a few centimeters of misalignment could have caused a disaster, forcing the team to remove the entire drywall ceiling system. But despite this extreme complexity, the pace of the construction site did not slow down. The technical bottlenecks had been solved, and the super tall tower was racing toward the finish line. After nearly 5 years of construction and countless battles, 1000 Museum was officially inaugurated in 2019. Rising above the Miami skyline like an alien creature descending from the sky, the tower's flowing white exoskeleton reflects the Florida sunlight, making it completely different from the box-shaped glass towers surrounding it. Imagine taking a quick tour inside. From the double-height lobby, where the exoskeleton columns extend directly from the exterior into the interior, creating the feeling of walking inside a giant rib cage. High-speed elevators carry residents to the apartment floors, with only 1 or 2 residences per floor and no 2 floor plans exactly alike. Inside, the curved walls are finished with cast-in-place plaster